On this week's episode of Collisionarium, we discover how to calculate the distance of the horizon.
Welcome to the Collisionarium.
Ancient civilizations believed that Earth was a flat circle floating in water. It wasn't until 5th and 6th century Greece that philosophers such as Pythagoras began to hypothesize a spherical Earth. If we look off into the distance, we can see the horizon. The horizon is essentially where the Earth's curvature drops off from our line of sight. Although the Earth is spherical, we can calculate the approximate distance of the horizon by treating our line of sight as a flat plane. How shall we do this, you ask? By consulting the aforementioned philosopher Pythagoras and his trigonometric theorem. You all remember Pythagoras' theorem, right? Of course you do. A squared plus b squared equals c squared. It's a simple equation that says that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. We can use these ratios to determine the distance of the horizon. In this situation, the 3 points of the triangle are our eyes, the horizon, and the center of the Earth. So, the first side of the triangle, A, is the radius of the Earth. Side B is the distance from our eyes to the horizon. This is what we'll be solving for. The hypotenuse, or side C, is the radius of the Earth plus the height of our line of sight. If you're at sea level, you can easily measure the height from the ground to your eyes. Otherwise, the higher you get, the more you'll have to add to the height of your eye line. But first things first, let's check back with our equation and rearrange it to solve for B, or in this case, D, the distance of the horizon. You may note that the additional h is dropped from the equation. This is a mere simplification, since the additional few meters is negligible in the scheme of things. So, our formula becomes d equals the square root of 2rh, where r is the Earth's radius, and h is the height of your eye line. The radius of the Earth is approximately 6,371 kilometers, or 3,963 miles. By using this information, we find that the distance of the horizon is 3.57 times the square root of h in kilometers and 1.22 times the square root of h in miles. So now we have a simple formula to calculate the distance of the horizon. All you need is the height of your eye line, which includes any additional elevation. So here's the part where you can plug in your own information. I'm at sea level with my line of sight at about 5 foot 3 inches, or 1.6 meters. By plugging in 1.6 meters for the variable h, I find that the distance of the horizon from where I am standing is 4.51 kilometers, or 2.8 miles. Hooray for math indeed! I hope you found this as cool as I did. It's amazing how we can figure out something like this by just using a little bit of brain power. For more content like this, please visit us at www.collisionarium.com.